Now, good day, class. Last class on regression analysis, we talked about what regression analysis is all about, the two types of regression analysis that we have. And if you remember that class, we tried to explain that regression analysis talks about the relationship between the dependent variable and one or more independent variable with the aim of forecasting or predicting the dependent variable, give it a fixed value of independent what? Variable, right? And we try to explain what simple regression is all about and multiple regression. That's under the simple regression, we try to explain the relationship between the dependent variable and independent variable. And under multiple regression analysis, we try to explain what the dependent variable and two or more independent variable is all about. And the last class also, we try to derive the parameter, the formula for simple linear regression analysis, which is what we have on the board. And we call this to be the actual formula. We call this to be the actual formula, and remember that we also have what we call a deviation formula. That the deviation formula for beta naught under the simple regression analysis is we have beta naught cap to be y bar minus beta 1 minus beta 1 cap s bar. If you can remember this, then under the beta 1 we have the deviation method to be we have summation xy all over summation what? Small this, right? And we can rewrite this to be summation x minus s bar y minus y bar all over what? Summation what? X minus s bar square. And irrespective of the formula that you use, we are expected to get the same answer. For today's class, I'm going to use the actual formula. Then you can also try this, or probably in another class, we'll also try to use the what? The other formula. So look at this example above. Look at the example above. Now, we have a political analyst studying the effect of number of hours of campaign, CH, and the percentage of votes received by the 6 candidates in the municipal what? Election. And these are the candidates, right? So we have candidate 1, Abubakar, Pius, Adekunle, Bola, Amadi, Michael, right? So the hours of campaign for Abubakar, according to them, or to this question, is 40. Why the percentage of votes received when Abubakar spent like 40 hours in campaigning was what? 50 votes. Then the Pius, we have 10 hours and was able to receive 20 votes, 30, 60 hours, 80 votes, 70, like that, up to the Michael. To show that the number of hours devoted by, the candidate then determine the number of votes they are expected to get, right? So they now proceed by saying that is to study the effect of number of hours of campaign on percentage of votes received, a researcher, right? A researcher specified the following regression. Now look at the regression model now. Then we have percentage of votes is equal to beta naught plus beta 1 cap, then the CH, hours of what? Hours of campaign. Hours of campaign. And remember in our analysis then that it is the hours or the independent variable here that determine what the dependent variable will be. It is only the independent variable that will change that will make us to know the value or the status of what? The dependent variable. So I can actually rewrite this. I can rewrite this to be y beta naught cap plus beta 1 cap what? X plus error term. And remember the last class that we tried to explain what the error term is all about. The error term is also other factors that can determine the dependent variable, but we don't consider them, or we decided to add them with constant. So what we are saying here is it is not only the hours of campaign that can determine the percentage of votes received by the candidates. It is not only, there are some other factors that can determine the percentage of votes that the candidate may receive, but we just add them constant and use only the word hours of campaign. We add them constant by using only the hours of campaign. Just like we are saying that the price of the goods, it is not only the price of the product itself that determine the quantity purchased for that product. There are some other factors like the taste of the consumer, the price of the related goods, the income of the consumer also determine the quantity purchased of a particular goods. But when we have those other factors constant and consider only the price of the goods, so we call those all other factors to be what? Error term. The error term or the white noise. That all other factors that can also determine the dependent variable, we add them constant. So now the first question is use the above data to obtain the least square estimate of beta naught and beta 1, right? And interpret the estimate of what? The beta naught and beta 1. So let's do this. Now, I'm representing my percentage of flow to be y, and the independent variable here to be what? Hours of campaign. So let's say we have y to be 50, 20, 30, 80, 60, and 60, right? Then we have the x to represent the hours of campaign, right? So this y represents the percentage of vote, while the CH represents the x to be what? Hours of what? Hours of campaign, right? So in using this, let's say we have 40, 10, 30, 60, 70, and 50, right? So irrespective of the formula we are using, whether the actual formula or the deviation formula, the structure of our table determine the structure, the formula we are using will determine the structure of our table. So now, if I'm using the actual formula, for example now, then I know that I needed what? X squared, right? I need the x squared, then I need what? Xy, right? The n here represents the number of what? Observation given to us. How many number of candidates do we have? We have 6, Abubakar, Pius, Adekunle, Bola, Amadi, and what? And Michael. So n represents the what? The 6, right? That's the number of observation. Then we have the x, we have the y. So in getting, let's say we are getting the xy, then after the xy, I'm getting what? X squared, right? I'm getting the x squared. So xy, we are expected to multiply this with this. So 50 times what? So let's say we have 50 times 40. This is 2,000, right? 2,000. Then we have 20 times 10. We have 200. Then we have 30 times 30. We have 900. 900. Then we have 60 times what? 80. We have 4,800. Then we have 60 times what? 70. This is 4,200. 4,200. Then we have 60 times what? 50. This is 3,000 class. This is 3,000, right? So the x squared, now we are expected to square each value of x or hours of campaign, right? So we can say 40 raised to the power 2. This is 1,600. 1,600, then 10 will be 100, right? 10 will be 100. We have 100, then 30 will be 900. We have 900. Then 60, we have 60 raised to the power 2. We have 3,600.